Hello and welcome to TidyX episode 166, TidyX's screencast where we go through and explain how our code works. My name's Ellis Hughes.
And my name's Patrick Ward. Thanks for checking in with us at TidyX. This week, we are continuing on from last week where we were exploring base R plots. And we started by building up a basic scatter plot. And we worked through, the basics of how to set up a simple plot and then how to kind of dress it up and make it look nice and make it look real sharp and add a legend and add facets and all those kinds of things. So if you're interested in some of the nitty gritty of that, check out last week's episode. This week we're continuing on
Yep,
with another pretty common plot type, line plots, and commonly used for things like time series analysis.
exactly. So, without further ado, let's get into this and get our data set that we're going to be using this week. We're going to
Mhm.
continue to use the Lahman package just because we like that data set. It's a nice sports data set here, and we're going to be filtering the batting data set to keep all teams between the years of 2000 and 2020, and excuse me, not by teams. It's batters. My bad.
Yeah.
Batters between the years 2000 and 2020 that have at least 100 at bats. And we're going to be keeping the year ID, which team this player was on, the league that this player was on, the runs and hits that that player had. So if we
Mhm.
quickly run that, and then we're also going to drop levels. And so this is going to apply to all the different columns of DAT, and we'll remove all the factor levels that we have and convert them into their actual character values. Because as we talked about last week, in team ID and league ID, there are some teams and leagues that are in the batting data set that no longer exist in the years that we're looking at. So it's not really useful, and base are if they're still in the data set as factors, they will get plotted, and we do not want to do that. So let's
Mhm.
drop the levels there and let's take a quick peek at the data set here. And so as you can see, we've got year ID, team ID, league, runs, and hits.
Mhm.
Cool. All right, what are we going to do to it next, Patrick?
Well, similar to last week, we decided to stick with all base R instead of going tidyverse. And if you're maybe in a setting where you can't load too many packages, so maybe tidyverse isn't an option, there's certainly settings where there's restrictions on what can be put on your computer. And if you're working in more base R, or you just want to work in more base R, like and subscribe. Let us know in the comment section that you want to see more base R, and we can certainly do that. This is the way that you would do a tidyverse group by in base R. So we're going to use the aggregate function, and the aggregate function, it kind of looks like whenever we build like a model where we have an output variable, a tilde, and then some sort of independent variable. So here, what we're doing is we're saying, hey, go grab the runs and the hits columns, bind them together in a little data set. We want to do this. We want to aggregate this by year. And if we had other things that we want to aggregate it by, we could add a plus sign after year. So maybe it'd be like year plus team or league. Yeah, we could totally do that. We're going to use the DAT data set. So we tell the aggregate function that's where it's going to find this data. And the function fun that we're interested in here is the mean. So we're going to get the mean of runs and hits by year for every year within the DAT data.
Sweet. So let's run that. Take a quick peek at the data set, and there you go. So we've got for every year, we've got mean runs of 51 and mean hits of 92.
And again, you could extend that out, that year ID out, if you wanted to add other levels to your aggregate function.
Sweet. So now that we've got our data set prepared, let's do some basic plots. And y'all may remember from last week, if you just do plot and pass in two variables here and you run that, look at that, you get a scatter plot. Hey, there you go. Are we done?
We're not done. We can make this look a lot nicer. We can see something's going on. The data kind of snakes across time. And this is time series data because we made it that way, right? We're aggregating by year ID. So instead of just doing dots, let's make it a line. Lines are pretty common for time series data. So all we do here is we change the type to L, and now we get a line. And if we want both lines and dots, we pass it a B.
Would you look at that?
All right, that's pretty cool. Last week we were super not pumped about the kind of circle dot. What if we want to fill those in?
Yeah, let's try that out. So the next thing we got to do is if we want to impact the dot, just like we did when we were building our scatter plots, there's the PCH argument in plot. So PCH, basically think of it as the shape of the point that you're going to be adding to this. And so we are choosing to use point type 19, which is a filled circle, a filled dot. So normally that the base point is just that open circle there. Now we have the opportunity to add color into our point there. But there's more than you can do because now we're using a plot type B. That means that there are lines as well. And
Mhm.
line types can be changed using the LTY argument, which you can see here on line 207. So we're going to set this to line type 2, and that's going to be just the little dashes there. Of course, there are many more types. If we change it to 5, don't know what that one is, but that is slightly longer. Ticks there, or I don't know, 15. I don't know how high this goes. Those are really small dots there. So
Little,
there's a variety of different line types. Pick whatever one makes the most sense for your situation.
yeah.
Um, yeah, so that's kind of how you can get your line points or your lines as well as your dots. But that's not all you can do, right?
Yeah, we could also dress this up even more. For example, in addition to changing the line type, we can change the size of the dots with the CEX argument, which we talked about last time. So we can make those bigger. We can also make the line width bigger. And then you can see that our Y limits, they're going to basically be set by R's plot function based on the data that's there. So we can explicitly say like, hey, we actually would prefer to see the Y limits go from 80 to 105. So let's go ahead and make those bigger. So when we run this, now we get, okay, it's starting to come together. It's starting to look like a nice, little time series plot,
Very
but there's more that
professional.
we can do. Yeah, there's more that we can do here. We can add some regression lines.
Yeah, let's do that too. So, like last week, you can just use an LM to calculate a linear model. This time, we're going to calculate hits based on year ID and say the data is based off of dat year. So, it's kind of a relatively small data set, but that's fine. And we're going to run that and call a summary on this, and that's going to give us our summary statistics here. So basically, it's saying that we would estimate a I guess this is because it's year. It's kind of a little funky here. A
For every
y-intercept.
1 year increase, yeah, there's a corresponding drop in the average league hits by, about half. But this you can clearly see from the data that this is it's a silly model because it's not really linear. We would have to model this with some sort of squiggle, some sort of spline or some sort of polynomial or something like that to capture the trend a little bit more because it's not a continuous decreasing slope. There is some asymptote that it's eventually going to hit, and
Yeah,
bottom out.
can't
And
keep
some
on
of this
going
is
down to
rule change.
zero. That'd be really
Yeah,
boring baseball.
yeah. And a lot of this is rule changes. If you remember 2000s to that, 2006 period was kind of peak steroid era, right? So hits and home runs and things like that. Sort of once the game went away from that, they cleaned up baseball, whatever. We saw a drop. So that's what we see here.
Yeah. But just as we did last week, you can also add your AB lines and additional decorators to your plots just by running the next function here. So we're going to again generate our base plot here. I think we've added then main, xlab, ylab to main being the title here. So let's make ourselves a little bit smaller. So now we have the title for the plot here. Then we've got xlab for year and ylab for hits rather than just putting the dat y year age and dat y year ID. Makes it a little bit nicer.
Yeah.
The next thing we're going to do though is we're going to run AB line on fit. We're going to set the color to be red. The line type is 2 again, which is those dashes. and then line weight is 3. Would you look at that? It's downwards trend, like we
Now
said
we
it was
see our
going to be.
regression line. And then the final thing we can do is just add to that regression line the confidence intervals and prediction intervals. So the first thing we're going to do is we're going to take that year data set and we're going to call predict with the fit, the linear model that we built. We're just going to predict and get point estimates. So now if we called our data set, we've got this column of predicted point estimates that come from the linear regression equation. To get the confidence intervals, um, we could have used predict and called the standard errors and calculated these manually, but it's easier to just use predict and pass the argument called interval and say we want confidence. And by default, you're going to get the 95% confidence interval here. If you want something different, you use the argument level. So level and then 0.9 or something like that.
Mm-hmm.
This produces is its own little data frame, and it gives you the point prediction, the point estimate, which we got from the predict function, and then the lower and upper for whatever level, in this case, 95%. We're going to go ahead and we're going to dress up this confidence interval data frame that we just created because we want to bind it to the original data set. So the first thing we're going to do is use the subset function, and we're going to say, hey, get rid of that fit variable because we've already predicted on our original data set. All we want to do is keep the two confidence intervals. And the other thing we're to do is change the names from lower and upper because they're not very descriptive, and because the prediction interval argument is also going to give the same column names. We're going to make sure that we explicitly say, hey, these were the confidence intervals. So we're going to call them CI low and CI high. Prediction interval is the exact same thing. All we do is we change interval to prediction. And this, because it's a prediction interval, is going to give a much larger interval than the confidence interval because it's now accounting for the residual standard error of the model. So it's accounting for more of the variance or more of the error that's within this model. So we grab that prediction interval, we do the same things. Now we pass this all together with cbind, and we
Cbind
have
is
our
column bind, by the way, to be clear what this means.
Columbine.
So
Yeah.
it's just like your bind calls in
Yeah.
dplyr, where it's going, I'm going to just smush them all together, and assume that everything's going to be happy and work out together. So all the rows are in the same order. In this case, it works, but you should always be a little bit cognizant of what's going on when you're doing that. So now we've got
Okay. Yep.
in dat year. We've now added in the pred, which was done, up here. Now we've got our conf intervals here, CI low, CI high, and then we've got our PI low and PI high for the prediction intervals.
We keep all the same kind of basic plot features the same. So this is our regression line plot. And now we're just going to add some extra lines with the lines argument. So these lines, this lines function is going to place these lines on top of the plot that's already displayed in our R console right there.
Mm-hmm.
So in this case, we're going to actually just call both the low and the high confidence interval. We're going to make them blue. We're going to make them also dashed lines, and we're going to give them the same line weight of 3. And then for the prediction interval, we're going to make them green, same line type and same line weight. And we're just going to throw that in there over top of the plot. And that's going to give us this cool looking plot where now we have our time series data, and we have some prediction intervals and confidence intervals in the regression line. And I guess the only final thing here, now that we're happy with our plot, Ellis, what if we wanted to save this so that we could send it off to someone?
Yeah, let's save it. So this is, clearly it being in our console is fantastic. We can see it. We go, cool. I see the pattern. It's downwards trend. Perfect. But I don't think you're going to get to go to a stakeholder and say like, hey, trust me, bro. Like it's going down. No, they want to see something. Want to save your results. And with ggplot and those sorts of tools, you can use like ggsave to save the outputs. In base R, you actually take a slightly different approach because remember, when we're plotting in base R, we're plotting things on a canvas. So this is a graphic device where we're writing things to, and it's recording as it goes and showing the results. That's why we're able to run these different functions where we run plot, and that creates the new canvas. Then AB line adds on top of that. Then these new functions, lines, adds lines to them. So we're kind of like building up and drawing new things on our canvas. So how
Just
do you
like we would in ggplot without the plus signs.
exactly? But in order to create this canvas where you're going to say, hey, computer, rather than writing it to my console here necessarily, what I want you to do is be writing this to a file. And the way you do that is we're going to create a path first. This is just going to go to a temporary directory, but this path here could be going to your local directory or some other directory. So just looking down here in the console in the lower left here, you technically could write like temp PDF is my path to greatness
Hmm.
.pdf, or it could just be greatness.pdf, and that would write it to your current directory. So in here, projects TidyX. If I then add my plots, then that would save it in the my plots folder in a file called greatness.pdf.
Yes.
So now once we have temp PDF, what we do in order to tell R that we want to start saving these outputs is we run the function, a function that is going to start up this new graphic device. In this situation, we're going to be generating a PDF. So we use the PDF function. We pass the path that we want to save the PDF to. And then there's a bunch of other parameters you could write here. Here we're only setting the width and the height of our PDF to be 5 and 5. It assumes you're writing in inches and requires you to be writing this in inches. So we're going to make a PDF that is 5 inches tall and 5 inches wide. If you
And there's
don't,
other generic functions too, like JPEG,
yes,
PNG. You could write to other things.
yes, there are many other functions other than PDF.
Mhm.
There's SVG,
The
there's
SVG is one, yep.
PNG,
Yep.
BMP, TIFF.
Mhm.
There's a whole swath of functions that exist in base R to save out to a lot of these common devices, as they call it, that you could do. So once you've started up your device, so here we're again saving to PDF, you just go as normal. You generate your plot, write your AB line. You may notice nothing is being written here to the viewer on the right hand side. And that's because it's capturing the output and sending it to our file as opposed to this graphic device over here. So again, run lines, 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 lines. Now in order to tell R, okay, I'm done writing to the graphic device, you can save it and we're done. You call dev.off. And what dev.off does is like now when we go to plot this, this will write it to our console again. Because we've now turned off the graphic device that it was writing to our file, and now it's just generating it as a new graphic canvas on in our R session here. So now if we want to see this, if you're in Windows, there's a handy dandy function called shell.exec. It's executing I'm not going to go into details, but either way, it's opening up this PDF for me to preview, and it's saved in my temp directories. So this
And it looks
path
like we
means
could have
absolutely
added
nothing.
some width where our header's kind of cut off. So we could have
Yes.
added some width to the plot.
Yeah.
But saving PDFs, whether it's in or JPEGs, or saving reports, whether it's in base R or ggplot, is something that is probably useful. If you want to hear more about that, like and subscribe, drop comments down below. Let us know that might be something that would help you in your day-to-day work in terms of producing deliverables.
Yeah. Or if you've ever come across a weird method of saving something, I'd actually love to hear what are the different ways that people have used these sorts of functions and have found kind of cool, fun tips and tricks. I mean, obviously, we're trying to share them with you all, but if you've used these in an interesting way, we'd love to hear the ways that you've used it as well.
Yeah.
So with that, we're going to call episode 166 of TidyX Plotting in Base R, the Line Plot Saga.
Huh.
With that, as always, my name is Ellis Hughes, and you can find me on various social media sites at Ellis_Hughes.
And my name is Patrick Ward. You can find me on X at OSPPatrick, at tidy_explained is where the screencast lives on X. Tidy.explained@gmail.com is where you can hit us up. But the best way to get in touch with us, probably the by far the easiest way is liking and subscribing on the YouTube channel. Drop in the comments down below. Let us know what you'd like to see more of, what would help you. And additionally, if you enjoy our work and you feel like it's helped you, we do have a Patreon page. We're always thankful for anything you'd like to give to support the show. And I think that said,
With that, thank you all so much. Keep on exploring your world.